Okay guys, the last thing under DC circuits that we're going to see is potential dividers. But before we start seeing it, let's watch a moral story.
Also spinning with pain.
I can never imagine that you will be so selfish.
You are selfish.
You.
You.
Stop, sister, stop. You both are foolish. Let's cut this bread into two, half for you and half for you. Both cats started thinking. No need to think so much. I will cut this bread for you. Half is yours and half is yours.
Blackie's piece is bigger than me.
Don't worry. I will make it equal. Monkey took the bread and ate a small portion of it and said, Now it's equal. Now Brownie has larger. I see. I will make it equal again. And he ate small portion again.
Again, Blackie's piece is larger.
Oh no! Both of you have frustrated me. I am doing great help of you. You should give me party after that. The monkey was very clever. He ate the whole piece of bread and said, I think now everything is fine. Saying this, both cats realized that monkey has cheated them and made them a fool. They took a stick and ran after monkey, but nothing can be done now.
So the basic idea of a potential divider is basically very simple. Now let's say you have a battery of say 12 volts. Okay. You have a battery of 12 volts. And you have two components, R1 and R2 connected in series, right? And we're going to say that the potential difference across R1 is V1 and the potential difference across R2 is V2. Okay? And let's say that the terminal potential difference of the battery is V. Guys, see the terminology I'm using? I'm not exactly saying EMF because EMF is that includes the internal resistance and the voltage spent there. So I'm saying terminal potential difference is V. Okay? Now it is the same current which is going to flow through the battery, through the resistor, through the R2 resistor as well, because this is a series circuit. Okay, which means that if you write an equation for the V1, that would be I times R1, and if you write an equation for V2, that would be I times R2. So the ratio of both of these voltages will be V1 over V2 would be equal to, if you divide these two equations, the i's will cancel off and you will have R1 over R2. So what we have done is, based on the ratio of the resistances, we have split up the total voltage, because we know that V should be equal to V1 plus V2, that is Kirchhoff's first law. Sorry, Kirchhoff's second law. So V is V1 plus V2, and we have divided that using R1 and R2. Okay. Now let's say that you want to, the thing is the battery will always give a certain potential. If it is 12 volts, that's going to give 12 volts, doesn't matter what is the resistance, what is the component that you're connecting it across it. If you have connected this R1 separately, then the entire terminal voltage would fall across R1, right? And if you have connected the R2 separately, then also the entire terminal voltage 12 volts will fall across R2. So if you just want, let's say, half of 12 volts and you don't have a battery of 6 volts, then the only option that you have is to use a setup like this. So when these resistors are put in series together, they divide the available terminal potential in the same ratio as their resistances. Okay, so this is the fundamental idea of a potential divider. If you want to have like equal, let's say you have 12 volts and you want to divide it into 6 and 6, then you have to use R1, two resistors of equal value. If you want to divide them into, say, 3 and 9, then R1 should be 1/3 of R2, because if this should be split into 3 volts and 9 volts, that is, the ratio is 1:3, then the resistance should also follow the same ratio. So R2 would be 3R1 and the ratio would be 1:3. Okay. So according to the resistor values that you are using, you will be able to divide these 12 volts. So you have to choose, in fact, not according to the resistor value that you are using, according to the ratio of the resistor values that you are using. Okay. This fundamental idea is called potential divider. If I were to name this thing, I would have named it as potential sharer rather than divider. The word dividing is very unloving and unkind.